Good afternoon, everyone. This webcast is Revit MEP Project Process, Part 1. There will be a second part. This first part mainly goes through HVAC setup and design, and the second part will focus more on the hydronics and plumbing. So with that, we'll get started. As I mentioned, HVAC, however, much of the information that I'll be covering here does translate pretty well into the other disciplines. And now for a project to be successful, it is important to have a well-defined workflow that gets our designers working efficiently, moving through that project. Also, having a template and good content is really important. It helps define your standards and also assists in your workflow. So once you've had your architectural model linked in and you've created and aligned your levels, then we go in and add and define our spaces. And I've got a Revit model here where I've already defined I've linked in my architectural model, and you can see I've got the architectural model and my first floor level and all my additional levels copied in here. Now I've already gone through and and added all my spaces automatically, and then I've used the space naming utility to make sure that all the names match with the architectural. So once you have them, you add your spaces. Now you define your spaces so that they meet the ASHRAE. Let me get back here. The ASHRAE guidelines and categories. So you can come in here and define your space. Is it active storage? Is it open office? And that'll help define our area per person, sensible and latent heat loads. We can also give a lighting and power densities. Now, one of the things that I've found useful when setting up my spaces is turning off my ceilings or turning them non-bounding so that they will push all the way up to the level above. And this becomes important later on when we go to export a GBXML to perform our load calculations. So it does a couple of things for us. Rather than going in and adding a plenum space, we can have the full volume of that space, and then once it gets into train, they don't have to go and delete all the plenum spaces, push the volumes all the way up to the roof or the next level, and then provide a plenum offset. They can just go right in and get the correct volumes and run the calculations. So back in Revit, let's say I've got this librarian workspace, I've got a VAV, and then I've got this kitchen area. As a for instance, let's say I want to put both of these into the same zone. We can come in, give it a zone, and we want to name that similarly to our VAV, so we can easily track that down. The next step would be to export the GBXML, and that's pretty simple Just coming in here, we've defined our building type. This particular building is a library. We've got our location. And then we can set our building construction up. And usually what I'd like to do is set my buildings up as code minimum so that anything that needs to be adjusted in train can be taken care of there. Then we just say OK and next. And now once you get it out to a GBXML, I don't have trace, so I can't demonstrate that. But you can, the nice thing about the information that comes through is you'll get all of your zones and your spaces, not to mention all of the square footages, areas and volumes and whatnot that come through, along with all of the space types, so that the person running the load calculations has a minimal setup, or as much as can be expected once they start modifying the model in trace. Now, the reason I mentioned trace is because of all the load calculation software that's out there, trace currently is the only one that I'm aware of that will provide a GBXML that we can then import back in. So if we go on to our next slide, we run our load calculations in trace. Then we export those load calculations as a GBXML out of trace and bring them back in. Now, if your model changes anytime between the export and the re-import, the information you get back from trace is not going to match up. But I will show you. So if I came into just a space airflow summary that I've set up. So here we've got our name, room name and number across the top, and I've embedded an air terminal schedule so that we get them listed below. But then I've added the actual airflow that the room is seeing, the calculated value that we'd get from trace, and then the difference between all of the supplied and calculated. So if we wanted to come in here, let's insert, import a GBXML, and I've got one available. Now we'll have all the results. These are the options that we have coming in from the GBXML. So we want to keep all of the calculated supply, cooling, and heating loads for spaces and zones. So if we say OK, now my numbers didn't change very much. But here, let me undo that real quick. But you'll see down here, it's 235, so let's go to insert, see if that changes. Yep. So my kitchen was at 351, now I'm at 223. So the next step would be to go through our Revit model and start adding our registers and diffusers. And normally what I like to do is come into a ceiling plan, say create similar, place on a face, and just as a for instance, we'll throw these in here. And these both have 0 CFM defined. So if we go back to our schedule, you'll see our workroom 2, we have 0 CFM defined. Now the calculated value is looking for 293 CFM. So if we go back to our model, I'm just going to blow these out of here real quick. Now we're back down to 2. So we can come in here and say 145, 145. And this is a really fast way of just kind of making sure that we've got all of our values plugged in and matching up with our load calculations. So that's our logical systems giving information into our spaces. Now we can come in here and let's say we want to put these 3 diffusers onto the same system. Just come up here, click duct, and I generally name my systems after my VAVs just to make them easy to identify. And at this point we have the option to select our equipment. Now if we look at our project browser, or system browser rather, we can see we have supply air, VAV, VAV1, and here are our 3 air terminals. So we can go back to our zone and space schedule. As I mentioned, and kind of work through this from the very top, and it should only take a few minutes to go through and set up all of your CFM values for your entire project. And if you ever have a question about is this a perimeter diffuser, then you can just hit highlight and model and it'll bring you right to it. And you can see that that is a perimeter diffuser as opposed to an interior diffuser. So if you want to, you could add a little extra to it. Take a look at that one. Come back in, 125. I'm guessing that these are all probably perimeter diffusers being linear slots. And that gives us a percentage difference. But we can keep going down the entire list and have this all taken care of for us pretty quickly. So as I mentioned, create your zone and space schedule and then embed an air terminal schedule. And then we can include the actual and calculated airflow parameters for the spaces. And then in our airflow, for our air terminals, we include the airflow and the connection size parameters. So you can see this has we've got an 8-inch neck on this one. These up here, 10-inch neck. And depending on how your family is set up, you can change it either here or if you have your family set up with lookup tables and air terminals. If I change this, oops, here, let me go back up. Nope. We'll get ridiculous. So that's just reading my CFM and calculating it, looking at a lookup table, and pulling out the neck size that will be required for that. And that's one of those things that if you have good content, then it's going to make your job a lot easier. So again, we we adjust our air terminal flow and match it to the imported calculated values. And now we can go back and create our ductwork layouts. And we can use generate layout, connect into, or we can manually draw them. So for instance, I have this system all set up. I can just come up here and hit generate layout. And it gives me a few options that I can pick from. I can also choose the solution type. Is it network? Is it perimeter? And that gives us some different, some layout options. Or we can do intersections. But for this demonstration, I'll just use the network. And under settings, this is where we define the types for our main. So it can be rectangular taps with mitered elbows, and how far off the floor is it going to be. Then we can set the same with our branch ductwork. It's round. I'm going to use 1 diameter elbows, set those at 14 feet. Now we could also put in flex duct as an option right now, but my personal choice is to not put in the flex duct right now, just because I have had issues with systems not being well connected, and we can always go back and convert those to flex duct later on. I say finish layout. It'll give me an error, and the error is just because this piece of ductwork does not have an end cap. Simple enough. Quick save it. Drops the cap on it. I'm going to go back to my floor plan. Oops. So you can see I've got 6-inch neck. Airflow is 145. And now checking our ductwork, Revit will automatically use a default sizing method, and that's basically whatever was last used in your duct size calculations, which right here I've got it set to 1200 and 0.1 to do velocity and friction. Now what we could do is we can take all these and, just as a for instance, bump them all up to 500. So if you had previously run all your ductwork and then went through your schedule and changed all them, you can quickly come back here, select it, hit your duct sizer, say OK. Everything resizes up to a proper value, and we can see that this has 1500 CFM flow. We're at 960 feet per minute and 0.0848 for our friction. Now you can do the same thing with your VAVs if you had several of them. We can say set up a ductwork, and we can call that RTU-2. And we want the supply air intake. And if we had a rooftop unit, we could say select equipment, which I actually think I have one somewhere. Maybe not. And the other nice thing is you can just select one individual unit and hit generate layout, and it's going to try and calculate that particular system. So I could say finish it. Now I've got a piece of ductwork here. The only thing that I don't care for about generate layout is that you don't have the option of choosing which section is main and which is branch. But it's simple enough to come back in and select all of them and either delete them and connect in. Actually, get rid of that transition. Now, drawing ductwork from units, from this guy, I'm just going to set them out here in space for now. But we can come in here, quickly hit ductwork, call him VAB 1-2, select our equipment. And we could come in and manually draw everything, call it 14 feet, draw one there, and come all the way down to here. Or we can use connect into. Let's delete that guy. Cap the open end. And you can see we have our 1500 CFM coming through. So using tab to select your entire duct system and then setting your sizing method, as I mentioned, to 1200 feet per minute or whatever your design criteria are. And then as your CFM value changes on the schedule, if you're getting updates to your rooms, you know, it's simple enough to come back in here and then tab twice and resize. And that's the HVAC portion. So a couple of questions. What exactly do I mean good content? Having properly set up content is really important, and by good content, I mean things with good connectors. So if we took a look at this particular family, we can see here's our air terminal. It's set to preset. So having all of our connectors properly set up, what type of system they are, even going as far as just linking them to proper parameters that we can adjust later on. And if you feel like getting really deeply into your content, you can start bringing in lookup tables that'll give you, things like noise criteria or neck size. But it's saying, for instance, the like the VAV, this particular family has got some formulas in here that calculate FLA if it were an electric reheat. It'll bring in our current rating, breaker rating, calculating delta T's for BTUs, and providing GPM for hot water reheat. Good content. Another question was, what category type of schedule is the my air terminal schedule or my space schedule? This particular one is a space schedule, but you could do it with a zone schedule because it'll look at the zones as well as looking at all the spaces within the zones, and then we're embedding an air terminal schedule into it. Another question is, at what point of the design phase is this intended for? We typically do not see a Revit model until after our design phase. I start my designing immediately. So if I have, even if I have architectural CAD drawings in DD, I'll start dropping in my air terminals. I may not put in my ductwork, but I'll start putting in my spaces and my air terminals so that I can start getting data that's going to help me design my systems, so that I can actually come in here and maybe during design development or SDs, this is all I have. I have a room schedule. I have an idea of the systems that I'm going to be putting in. Is it constant volume? Is it variable air? What are we doing? And I will basically work off of this schedule from the very beginning. And then once we start finalizing layout, if we finally get a ceiling grid, then I can start, aligning to ceiling grids. I can, my wall shifted and I need to pull my diffuser off the wall. Or somebody put a light there and, the lighting layout is more important than diffuser layout. So there's a lot we can do before we actually get to the duct layout, as long as we're using, like I said, good content. Are these type of schedules included in the MPP package offered by CTC? Yes, they are. All of the content that you see, let me go back, is included. We've got an airflow summary schedule. This is more like the one that you will see. For this demonstration, I wanted to show a little bit more information, use some conditional formatting so that we could highlight the diffusers that I will be changing. Is there any other questions? I don't know if any of you noticed, but as I change the CFM, you'll notice that my neck size changes. Oops, not 200. based upon, come on now, there we go, based upon my CFM values. And that's also driving my noise criteria. I'm getting velocity pressure, static pressure, pressure drop. We're also calculating our throw distance for that air terminal. Another question just came in. What issues do you typically run into when exporting the GBXML, and how do you address them? The biggest issues I've run into is the size of roof that happens to be over a space. Typically, we'll just manually fix that. I've had a couple of issues with walls that get broken up. As a for instance, let me change this. This wall here might come in as a couple different broken up surfaces. So we will have to go in and combine those wall links together